In this video, we are going to continue where we left off in the last part, and we are going to start the development of the YouTube clone project. So we are first going to create the data model in our Spring Boot project, and following that we will create our first feature. So we will see how to set up our Angular application to upload the videos, and how to configure our backend application, and also to set up the AWS S3 account and how to upload videos into AWS S3. So without any further delay, let's start the video. Alright, so before we start the development of our backend project, so let's have a look at the MongoDB schema which we are going to create. So I'm going to open the blog article here. Here you can find the schema diagram. I'm going to click on the section MongoDB schema, and here you can see that we have the two collections mainly. First collection is a video collection where we store the metadata related to the videos. So that would be the description of the video, the title, the user ID which is associated with the video, and the counts of the likes and dislikes. So a user can like or dislike a video, so we will maintain this count in these fields. And we will also maintain what are the list of tags which are associated to the video, followed by the URL. So this URL will be the S3 URL. So once we upload the video to AWS S3, we will get a URL where we can access this particular video. So we will store it in this field. And a video can have different statuses, as I have mentioned before in the first part. A video can be a public video or a private video, or it can also be an unlisted video. We have this view count where we are going to record the number of views for each video, which is similar to your YouTube videos you see. And we also have a thumbnail URL where the user also has the option to upload an image. And we will also store this image inside AWS S3, and we will store that image URL inside the video collection. And next we have a list of comments. So the users can of course also comment on the videos, and we are going to store this comment as a document inside the video collection, but we are not going to maintain it as a different collection itself, because the main idea of MongoDB is we have this flexibility to store the documents inside one document, so we can have very large documents. So we are going to leverage that, and we are going to not going to create any relationship between the video collection and video and comment. So if you're talking about a relational database, so for sure we will have a video table and we have a comment table, then we will have a one-to-many relationship between them. But as we are using MongoDB, we don't need to do that actually. So we can just embed the comments, all the comments inside the video document itself. Yeah, the next one we have is the user collection, where we will store the metadata of the user itself. So we have the usual first name, last name, full name, field email is missing here. So we have the subscribed to users and subscribe users. So we will just maintain the subscribers, we maintain the list of users which are subscribed to a particular user. Yeah, we also have the video history. So we'll maintain the list of videos which the user has visited in this particular field, and we will also have the list of liked videos and the disliked videos. So this is how the database schema looks like. So now let's go ahead and implement this schema in our Spring Boot project. Alright, I'm back to the IntelliJ IDEA, and here I'm inside the backend project. And what I'm going to do here is to create a new package. So I'm going to right click on the root package and go to new and package. And I'm going to name the package as model. So here we're going to create the database entities for the MongoDB. So I'm going to create a new class called as video. And in here, the first field which I'm going to create is going to be the ID. So it's going to be private string ID. So this is going to be an identifier. So I'm going to use the Spring Data MongoDB annotation called ID. So just to make sure that we will inform MongoDB that this is the identifier for this particular collection. And next we have the title field. So this is going to be a string variable followed by the description. And we also have the user ID. So this is also going to be a string here. So notice that while storing this ID inside the MongoDB database, this will be converted into a different format. So this will be stored as an object ID, but we are just informing that an object ID should be of the type string. So whenever you read the read the entity from the database, you will be having this ID as in the string form, but not in an object ID format. Okay, so that's one thing we have to keep in mind. Okay, moving ahead, we have the likes count. So we are going to maintain an integer variable called likes, and I'm also going to define an integer variable called dislikes, followed by a set of strings. So I've mentioned tag should be a list inside the schema diagram, but this should be a set of strings. So I'm going to define a set of string, and this is going to be, we are going to name it as, and this we are going to name it as tags. And let me also make sure to import this into the class. And the next field I'm going to define is going to be URL. So private string URL. You know what, let's name this as video URL, because we also have a thumbnail URL. So the next one is going to be an enum called as video status, because whenever we have multiple possible values, we usually use an enum type. So let me quickly create an enum. So create enum video status. Okay, and the possible values here are public, private, and unlisted. Okay, so the values inside the enum should be all capital. So I just capitalized each possible values here. So public, private, and unlisted. Okay, so let me go back to the class, and the next one is going to be an view count. So we will maintain the count of the video. So we will maintain the count, how many times a video is being viewed, followed by the thumbnail URL. So this is also going to be a string, and I'm going to name it as thumbnail URL, followed by the list of comments. So we don't have any comment class yet, so let's leave it like that and name it as comment list. So what I'm going to do now is to create the class called as comment. I'm going to create it inside the model package, and in this class we are going to again create an ID from the Spring Data Annotation, Spring Framework Data.Annotation package, and I'm going to name this and create the field called ID here, followed by the text. A comment can have a text, and we also need to store the user ID of the author. So I'm going to name it as author ID. I think that's fine. We can also have the possibility to like or dislike a comment. So we can also store the like count of a comment. So that's going to be an integer. And let's do the same thing also for the dislike count. All right, so let's import this into our video class. So looks like everything is fine, but what we are missing here are the getters and setters, and the no argument constructor and the all arguments constructor, which are essential for the for any Java Pojo class. But before that, we have to define this particular class as a MongoDB document by using the document annotation, and we can name it this document as video. I'm going to name it as video, followed by the Lombok annotation. So instead of generating the getters and setters and the no args and the all args constructor, I can use the Lombok library, which we have added before. So to add all this boilerplate code, I can use the data annotation from the Lombok library. So if you go ahead and open the structure tab, so if you're using IntelliJ, if you open the structure tab, you can see that Lombok has automatically created all the getters and setters for all the fields which you have specified. So you can also see that it has created the equals and the hash code and the toString methods automatically. So this is created dynamically by Lombok at the time of compilation. So you don't need to implement them manually. Let's also add the arguments constructor. So I need one no arguments constructor and all arguments constructor. Okay, so let's now create the user collection. So I'm going to go back to the model package, and I'm going to click on new Java class, and I'm going to call it as user. And let's do the same thing also. I need to define it as a document, add all the Lombok annotations. So I'm just going to copy it from the document class and paste it here. And I'm going to rename it as user. And inside we will have our first field. So this is going to be again an ID. So I'm going to add the ID annotation from Spring Data. And I'm going to name it as private string ID, followed by the next field. So this would be the first name, last name, and the full name. So these are the three attributes of a user. The name of the user, followed by the email address. So I can create another variable called email address. And I'm going to create a set of string. I'm going to create a subscribed to users. Let me import this set, and I'm going to again create a field called as subscribers. So this list will maintain the list of users which are subscribed to our given user, and the subscribed to user will maintain the list where our user is subscribed to another set of users, right? Hope it makes sense. And the next one the next field we are going to create is going to be a video history. So this is also going to be a set of going to be a list. So list of string, and we are going to name it as video history in this field. Let me also quickly import this field, followed by the set of liked videos. So this is going to be again a set of strings. So we're going to name it as liked videos. Let me copy again and paste it, and I'm going to rename this as disliked videos. Alright, so we have the main collections. We have created main entities inside the Spring Boot project. So we have the video entity, we have the user entity, and we also have the comment class, which is going to be an embedded document inside our video document. And one thing I've missed is I did not add the getters and setters here. So let me quickly add the data, the noargs constructor, and allux constructor annotations here. So yeah, now there are no squiggly lines under the field name. So let's test this out. I'm going to start the YouTube clone application, and it should be started without any errors. So yeah, you can see that it has already started up quickly. Alright, so the next step is to start developing the first feature of the application, that is to create an endpoint to upload the videos to our server, and from there we will upload the video to the AWS S3. So let's briefly have a look at how we are going to approach this this feature, right? So we'll have some users who are going to upload a video to our backend server. Our server will mainly expose a REST API, REST endpoints, that is mainly handled by a controller. So we will have a controller which will expose a REST API, and then will process the files which the user is uploading. And after processing the file, we will delegate the logic to upload the files to the service. So we will also have a service class which will mainly deal with uploading the file, like processing the file, and then we will upload this file to AWS S3. So here we have AWS S3, right? And after that we are going to mainly store the metadata of the video inside the database. So we will also have a repository which will talk to the MongoDB database, right? So this is the high-level overview of how we are going to structure our backend project. And so we will have a controller, service, and a repository. This is common for all the APIs we are going to create. All right, so now let's go ahead and implement our first API to upload the video. For that, I'm going to open the IntelliJ IDEA, and then under the root package, I'm going to right click and create a new package called as controller. And under this package, I'm going to create a new class called as video controller. And as this is going to be a REST controller which is going to expose a REST endpoint, I'm going to annotate this class with the REST controller annotation followed by the request mapping annotation, because this is where we will tell to Spring Boot where we can find the REST API. So I'm going to name this mapping as /API/videos. Alright, and now inside the class I'm going to create one method, public void upload video. Alright, and this method will take a request body as a file as a request body, right? So this is going to be, we have to define a request param as a file, and the kind of file which we are going to receive is going to be a multi-part file. This endpoint is going to listen for the post request, right? So this we have to also add the post mapping annotations on top of this class, and the HTTP response of this request is going to be created. So I'm going to use the annotation response status, and in there I'm going to type in HTTP status dot created. So I'm going to select the option HTTP status dot created. So usually whenever we make a post request, we are creating some resource at the server side. So the appropriate return type whenever you're doing a HTTP post request, the response type should be created. So just keep that in mind, okay? All right, so moving along, we have to send this file to the service, so that we have to process this file and we have to delegate it to the service layer. So for that I need to create the video service class, and I'm going to create this inside a package called as service, and inside the package I'm going to create a new class called as video service. Alright, so now I'm going to annotate this class as a service, and in there I'm going to create a method called as upload video, and I'm going to take in the multi-part file as the input parameter. Alright, so now inside this upload video method, what we are going to do is to upload the video file to AWS S3. So I'm just going to list down here upload file to AWS S3 and save video data to database. So this is what we want to do, and here as this is a video service, it makes sense to not code the logic upload the file to AWS S3 inside this class, right? So it makes sense to create a separate class called as maybe an S3 service. What I'm going to do is I'm going to first create an interface called as file service, because we are just going to follow along with the best practice that we have to program against an interface, so that in future if we want to create more implementations, we can just extend that interface and create some other class and make it polymorphic, right? So I just made a mistake here. This is going to be a file service, so let me rename that quickly. Perfect. So now I'm going to create a class called as S3 service, which will implement this file service. So in the future, if I want to, if I don't want to upload the files to S3, but I just want to maintain it on my own server, right? I can implement whatever logic I want to have, right? So now let's create the class called as S3 service. So this S3 service is going to implement the file service, and this is also going to be a service, so I'm going to quickly add the annotation here. So this class is going to implement the method called as upload. So I'm going to create a method with public, and the return type of this method is going to be a string, because we will once we upload the file, we will get the URL of that particular video. So this is going to be return type, and I'm going to name this method as upload file, right? So this is going to take a multi-part file as an input parameter. Now we have to also add this the method declaration inside the file service. So for that I'm just going to add the override parameter, and now the IDE will complain that this upload file method definition is not present inside the inside the file service. We don't need to add this manually, so we can just make use of our IDE. So I'm just going to Alt enter, and I'm going to add select the option pool method upload file. So if you go back to the file service, you can see that the method definition is added automatically to the interface. That's perfect. Now we have to add the logic to upload the file to AWS S3. Alright, so now let's go ahead and create an account for Amazon AWS so that we can access the S3 service. So the first thing I'm going to do is to go to the aws.amazon.com. So in here, create an AWS account. So if you don't have an existing account, you can create a new account, and they provide a free tier for 1 year. So we can visit this aws.amazon.com/free link, so to see what are the free services Amazon AWS will provide us. So we'll get 5 GB of free storage for 12 months. So you can easily use this free tier, and you can just experiment with all these services. So we will mainly use AWS S3 for this project. And once you have created the account, we can log in into the AWS portal. And in there, the first thing you have to do is to create an access key and a secret for your account. So you can do that by clicking on the account name to the top right side corner. My account is called as Programming Techie, and in there you can go to the My Security Credentials section. So in here you will have your credentials and the secrets which are associated to your AWS account. And if you expand the access keys section, here you can see the access keys which you can use to communicate with the AWS services from your application. So in our case, when our Spring Boot server want to upload a video file to AWS S3, we need to provide the access key ID and the secret for us to authenticate and then start the video upload. Right? So I already have the access key already created before, so you can click on this create new access key button. So it will show you this confirmation that the access key is created successfully. And if you expand this show access key section, you will see an access key ID and a secret. So make sure you save these two details. You can also download the key file. So I'm just going to close it here, and I don't need it. I will just delete it. And yeah, the next thing we have to do is to then configure AWS S3. So for that, I'm going to search for S3 here in the search bar. So I'm going to select S3. And in here, we want to create a bucket. So Amazon S3 stores all our files in something called as a bucket. So we need to create them. I already created one bucket. So you can just click on the create bucket option, and in there, make sure you provide some unique name, because AWS S3 buckets have a unique name. So you just provide some unique name and the region you will based on the country you are in. And then you can just click on create bucket. The bucket will be created, and now you're ready to access Amazon S3 from your Spring Boot application. So let's go ahead and configure S3 in our project. Alright, so now to enable the AWS support, we're going to use the AWS Spring Cloud AWS project. Go to the website awsspring.io. So now if you click on the get started button, it will open some introduction section, and if you click on the reference documentation, it will open the reference documentation here, and inside the reference documentation, if you just scroll down, we'll just have a nice overview about this project. So it provides some nice abstraction to access different AWS services from our applications. So you can see S3 is one of the service. We also have CloudFormation, EC2, relational database of Amazon, and some other services. So if I scroll down, you can see the dependency management section, and in here I'm going to copy this section, and I'm going to open our project, and in there I'm going to open the pom.xml of the backend module, and I'm going to scroll up and paste it inside our project. So I don't need the dependencies section here. So we have copied the dependencies, but for version we don't know what is the right version for this library. So what I'm going to do is press Control Space, and IntelliJ will suggest what is the latest version which is available for this library. It is 2.3.0-RC2. I'm going to select that, and make sure you force IntelliJ to download this dependency by clicking on the Maven icon to the top right side corner. Alright, so now IntelliJ should download this dependency and let's go back again to the documentation section, and this will download the AWS SDK to our project, but we need to also enable the auto configuration, the Spring Boot support for AWS. So for that we need to add another library. So I'm just going to scroll down here and I'm going to go to the section Spring Boot auto configuration, that's 2.3.3. And here we have another dependency. So I'm just going to copy the dependency part here. So this is for the dependency Spring Cloud AWS auto configure. So I'm going to open IntelliJ again, and just below the dependency of Spring Cloud AWS context, I'm going to paste in the dependency Spring Cloud AWS auto configure, and we are going to provide the same version number also for this dependency, and again make sure to force Maven to download this by clicking on that button. Okay, so now we have configured our pom.xml to download this AWS Spring AWS support. Now the next thing we need to do is to configure the credentials inside our application.properties file. So I'm going to open the application.properties, and in here we need to configure the Amazon S3 credentials. So if I open the documentation website, go to the configuring credentials section under the Spring Boot auto configuration. So you can see that we have this properties cloud.aws credentials access key and cloud AWS credentials secret key. So I'm just going to copy this property and paste it here. So here we have to provide the access key which you have copied from your S3 portal, from Amazon S3 portal, and similar to the access key we also have to copy the secret key for your Amazon account. So now the tricky thing is you cannot just maintain this access key and secret key inside the application properties, right? So because we have to maintain this files inside GitHub, we will upload the file into the GitHub, and it's not a good idea to maintain the access key and secret key of your Amazon account inside GitHub. So right, so for that what we can do is we can make use of the VM properties in your IntelliJ in your IDE. So what I'm going to do is I'm going to configure my credentials in the VM configuration by clicking on this YouTube clone application drop down here, and I'm going to click on edit configurations, and in here if I just expand the environment option, we see the options called as VM option. So here what I can do is I can inject the access key and secret key so that I don't need to maintain the these two properties inside the application.properties, but whenever Spring Boot this application YouTube clone application is started, IntelliJ will inject these properties automatically to our application. So I can just type in here -d cloud.aws.credentials.secret key. You can first provide the access key information here. So I'm just going to copy this one more time and add -d cloud.aws.credentials.access key equals my access key, and then again I'm going to press enter and type -d cloud.aws.credentials.secret key equals my secret key. So what you need to do is to paste this access key and secret key of your account here and just click on apply and OK. So now whenever you start the application, IntelliJ will inject these two properties to our application, so we don't need to maintain it anymore now. And moving along, we have the next property we are going to define inside the application properties is going to be the region. So I'm going to type in cloud.aws.region.static equals EU West 2, because I'm choosing EU West 2 because this is where I'm located at, because you can see that under the Amazon S3 portal you can see the AWS region where you have created the bucket. So I can just copy the EU West 2 text here and paste it back inside the application properties. And the last property we need to add is cloud.aws.stack.auto equals false. So this property will make sure that it will not enable any properties regarding the cloud formation. We don't need that right now. Alright, so now let's open the S3 service class and let's go ahead and implement the logic to upload the file to AWS S3. So the first thing I need to do is to get the extension of the file. So what we have to do is first to prepare a key, so that a unique key for a file, so that we can upload this file with this unique key to AWS S3. So to prepare this unique key, first I need to retrieve the extension of the file. So I can do that by first getting the name of the file. So I can now type file.get original file name, and after I get the original file name, I can retrieve the extension by using the utility class from Spring Framework called as string utils. So make sure you select the string utils from Spring Framework package, and then type get file name extension. Right, so I'm just going to pass in the original file name, and then we will receive the file name extension of the file we just created. I'm just going to rename this as var. Alright, so now we got the extension. Now to prepare the key value, I have to generate a random UUID and append the extension to that UUID to create a unique value. So what I want to do is create a UUID, UUID.random UUID dot toString, and concatenate the file name extension. Right, so this is what I want to do, and let's introduce a new variable and let's call it as key. Use a var instead of a string. Alright, now what we have to do is to create the object metadata. So I'm going to create a variable called as metadata and create an object metadata. So this object metadata is a class from this Amazon S3 module we just added. So now I'm going to add the content length. So I'm going to just add set content length is going to be file.getSize, and another metadata I'm going to add is the content type. So it's going to be file.get content type. And once we have the metadata object ready, now we can just directly send this file to the Amazon S3 using an Amazon S3 client. So quickly auto-wire this S3 client field. So I'm going to do a constructor injection here. So I'm just going to define a private final variable called Amazon S3 client. So again, I'm going to import the Amazon S3 client from com Amazon AWS services.s3 package. So I'm going to name this as Amazon S3 client, and now IntelliJ is going to complain that there is no constructor. So I'm going to press Alt Enter and add the constructor parameter. Using Lombok, we can also remove this constructor. So what I will do is I will remove this constructor, and I'm just going to add the annotation required args constructor. So what Lombok will do, it will automatically generate the argument constructor for us. So I'm just going to use the AWS S3 client variable here inside the method, AWS S3 client dot put object, and I'm going to select the object. So the first argument should be the Amazon S3 bucket. So if I open S3, so this is the bucket I've just created, YouTube demo ptechie. You can just provide the name of the bucket you have created. So I'm just going to type in my bucket name, YouTube demo ptechie, followed by the key which we just created. So I'm going to provide the key as a next argument, followed by the input stream of the file. So I'm just going to type in file.get input stream, followed by the metadata we just created. So I'm just going to add also the metadata there. And as we are accessing the input stream, it is throwing an exception here. So we have to handle this exception, surround this statement using a try-catch block. And I'm going to catch the IO exception here. And I'm going to rethrow this exception called as response status exception. And whenever this exception occurs, we are going to provide the HTTP status as internal server error. So that means something went wrong while processing this request. and we can just provide the message as an exception occurred. Just let me add it to the next line. An exception occurred while uploading the file, right? So this will make sure that it will create a response automatically to the client, and it will send this message as the exception message. So after we have uploaded the object to Amazon S3, what we can do is we can add some access control list. So to make this video file public, so that we can read this video publicly from our Angular application. So for that I need to do Amazon AWS S3 client dot set object ACL, and in there I'm going to provide again the bucket name. So I'm just going to copy this here and paste it, and followed by the key which we just provided above. And now I'm going to provide the access control list as scanned access control list dot public read. So this will make sure that we are able to read this particular file publicly without any authentication. So next we have to retrieve the URL of this particular video we just uploaded to S3. We can do that by typing AWS S3 client dot get resource URL, and we are going to again pass in the name YouTube demo beta key. Again, this would be the bucket name you have just created, followed by the key. Alright, so we can just return this URL we retrieved from AWS S3 back to the video service method. So that's what we need, right? We want to first upload the file to AWS S3 and return the video URL back to the video service. So let's just do some cleanup here. I'm just going to remove these comments, and we can do some improvements here because we have this YouTube demo beta key string multiple times. What we can do is we can extract this string into a constant. So what I'm going to do is make sure to select this particular string and type and press the key combination Ctrl-Alt-C if you're on Windows. So what this will do is it will create the constant, and it will ask whether to replace all the occurrences of this string or not. So we want to replace all these occurrences, so I'm just going to click on replace all occurrences, and I can also type in the bucket, and I can also decide what name I have to provide for this constant. So I'm just going to type in bucket underscore name. So if you just scroll up, you can see that IntelliJ has automatically created the constant called as bucket name. And yeah, if you want to change the bucket name, you can just change this constant, and you don't need to change it everywhere inside the code. Alright, so we have implemented the file upload functionality. Now all it's remaining is we have to call the upload file method of the S3 service from our video service. So what I'm going to do now is to auto wire the S3 service class into the video service. So I'm going to type in private final S3 service, and we are going to use Lombok to create the required arguments constructor. So I'm going to add this annotation, and inside this method I'm going to remove the comments and type in S3 service dot upload file, and I'm just going to pass in the multipart file to this method. So as a return type, we will get the video URL from the S3. So we are just going to name this variable as video URL. I need to create an object for the video class. So what I'm going to do is create a variable called video and create the object for the video class, and I'm going to set the video URL through the set video URL method, and I'm just going to pass in the video URL. Okay, so this is the minimum functionality we need to save the video. So what we need now is we need to create a repository to save this video to the MongoDB database. For that, I'm just going to create a new package called as repository, and inside this package I'm just going to create an interface called as video repository, right? And this repository will extend a Mongo repository interface, and we are going to create this repository for the entity video, and the primary key will be of type string. So we have to pass in these two generic arguments for the Mongo repository interface. So that's all we need to do. And next I'm going to again auto-wire also the video repository to our video service class. So I'm just going to type in private final video repository, and inside the upload video method I'm just going to call the video repository dot save video. So what this will do is it will save the video to the MongoDB database, and all that's remaining now is to call this upload video method of the video service from our controller. So let me open the video controller, and again I'm just going to add the required args constructor annotation on top of the class. And inside the video controller I'm just going to auto-wire the video service, and inside the upload video method of the controller I'm just going to again call the upload video of the video service class and just pass in the file as the input argument. Alright, so I think we are done here. So we just created the endpoint method to upload the video, and this is this is returning the HTTP status created as the response. And if you go inside the upload video method, it's first calling the S3 service, the upload file of the S3 service, and as part of this class we are uploading the video. We are just first creating the unique key and then uploading the video to the bucket we just created. And we are also setting the access control as public read so that the video will be visible to the Angular client. And then we are retrieving the video URL from AWS S3, and after that we are just saving the metadata to the MongoDB database. So that's it for this video, guys. In the next video we will see how to develop the Angular part of this feature. So we are going to develop a drag and drop functionality where the users can just drag and drop the video, and then we will call the Spring Boot API from our Angular application and then upload the video to Amazon S3. So I will see you in the next video, and until then, happy coding techies.